Often when we have a set of data, we want to fit it to some functional form, and the way we usually learn to do this at first is fitting a line to our data. So here I've got some data, and I'm going to look at this and I say, hey, I'm not sure that this is linear data. Perhaps there's some other functional form that would better fit my data than a straight line. Now in Excel I've got a few other options of equations that I could fit to this, but it has a fairly limited set. So we're going to use Matlab in order to do that. I'm going to show you how to do this in Matlab online. So this is matlab.mathworks.com. You need a MathWorks account, and we have a site license available for this. So the instructions for that are separate from this video, how you get your account set up. But I'm going to log in here, and it's going to bring up an online version of the Matlab tool. You can do all of this in the full version of Matlab as well, but the online tool is nice because we can access it from anywhere, and we don't have the large footprint of that piece of software running on our computer. So here I've got my Matlab layout here, and so what I'm going to need to do is get my data into here. There are several ways you can get your data in, but if we're just working with simple set of data like this, the most straightforward way to do this here is I'm just going to type x equals, I'm going to put an open square bracket here, and then I'm just going to go paste in the data that I want. So I'm only going to get the numbers and not the heading I've got at the top here. So I'm just going to go paste that in, and then I'm going to put a closed square bracket. So that's going to make an array for me of data. And then I'm going to do the same thing for my y data. I could call this anything I want. I don't have to call it x and y. I can call these things anything I want to. So again, I'm going to do an open square bracket. I'm going to paste in my data and a closed square bracket. You'll notice that over here on the variable workspace, those are going to show up. So if I double click on the y, for example, we can see here that we've put this array of data in here. So we can feel pretty good that that's what that looks like. Okay. Up here on the top, there's an apps thing, and there's a curve fitting tool. So that's one way to get to it. The other way I can get to it is to just type CF tool. So either of those, typing that in or clicking this button, are going to take me to the same place, which are going to bring up this curve fitting toolbox that's available in Matlab. So I'm going to bring this over here, and it takes just a second to load, and then we can work with our data once that's available. Once it loads up, we're going to have to choose what our data is. So we're going to work with two-dimensional data. So I'm going to pull in my x data. That's the thing I called x conveniently, and my y data here. So I didn't have to use those names. I could access them any way I want. And so here it plots my data on here. And by default, it's choosing some function, a polynomial function of degree 1. And if I wanted to try using different types of functions in here, I could click on these and it would do its best to fit that functional form. So this would be a times the exponential of b times x. But that again obviously doesn't look like a very good fit. But let's say I have a thought as to what is the best functional form to use. So I think this looks sigmoidal, so I'm going to use what's called a logistic function to fit this particular set of data. So I'm going to define a custom equation that I want to fit here. So I'm going to click on this set of options, and I'm going to just choose custom equation, and now it gives me this thing. So I'm going to say y is a function of x. Again, if I wanted to call these different things because I had different names, I could do that as well. And now I'm going to type in my function. So this is the functional form over here on the left of a logistic function, and so I'm going to type that in here. So I can use whatever variable names I want. So I'll just use the ones that are in my function here. So I'll do L over and then I'm going to do 1 plus the exponential of minus k times, and then I'm going to have my x value minus and then x naught. So my variable names also don't have to be a single letter, they could be multiple letters. So I can call them whatever I want here. It looks like I'm going to need 3 sets of parentheses. And then I'm just going to click outside of this box. And voila, it goes through and uses a fitting model to find the best fit for that. So I've expanded this back out here so we can look now. So I've typed my function in here, and now if we look over here, here's the general model. So this is the function that it was fitting, and then these are the variables that I introduced. So these are the fitting parameters, and so L, K, and X sub 0, and so it modified these 3 parameters until it found the best fit to my data. Now there's a lot of extra numbers here. So the best fit was to set L equal to 0.9945. And then these are the 95% confidence bounds. So this is one way of estimating the uncertainty of the fit, which becomes important later on when you're reporting data to explain how well you know a number. So this is one way of reporting how well you know that number. So this is a measure of uncertainty. So that's what these are, these 95% confidence bounds. And then we have all kinds of other measures of goodness of fit. The one you're probably most familiar with is the R-squared value, but there are all kinds of other ones like the root mean square error, the sum of squares errors. So there are a bunch of different ways that we can report those uncertainties in the fitting. So let's look at a few things we can do with this now. So let's say I'm wondering, does my function level off here or does it continue to rise a little bit? I could click on this button here. This is the adjust the axes limits button. And I'm going to move this up here. And let's say I wanted to say, hey, what does this look like if I took it out to 4 instead of at the end of my data? So I can project out and see what my function looks like if my data were to continue and if it actually fits this model. So I can do that and adjust those axes if I want to see how that would project out. So that's a nice little feature there. Now, let's say I want to get this out of here and I want to edit it because there's some things I don't like about this figure. There's a lot of stuff I could do. So I'm going to go up here and I'm going to print this to a figure. And that's going to bring up a figure here. And this is something I can now edit. So I'm going to go click on Tools and Edit Plot. And now this is going to allow me to make a really nice figure by modifying some of these properties here. So for example, let's say I want to get rid of this legend, I could get rid of it, or alternatively, instead of getting rid of it, if I wanted to edit the name of it, I could go here, and if I wanted to change those to be nicer names, I could do that. So I got a lot of different options here as I go through and edit. There I double clicked on my axes grids there, and so now I can do things like turn off my X and Y grid if I want to make a nice publication quality figure. And there's lots of different things that I can do as I go through here. So instead of calling this X and Y, I'm on my X-axis, so whatever my coordinate is here, I could give that an appropriate name. I click on the Y-axis and whatever that happens to be, and I can do all that kind of nice editing. So it's got a nice graphical editor, so if I want to make really nice publication quality figures, that's often a little bit easier to use than perhaps working in Excel. So I get some kind of figure here, lots of modifications I could make to improve this figure, and then I want to get this thing out of Matlab so I can incorporate it into my written publication. So I'm going to go here to Save As, and I have a bunch of different choices here of how I want to save this. So like I could do a JPEG. It turns out the resolution's a little bit low on that, so there's some better choices you might have, like a TIFF or an SVG. Just to show you that you can get really high quality stuff out, I'm going to do it as a PDF for a moment. You got a bunch of different choices. So I'll just call this logistic, and I'm going to save that, and then so after that I'm just going to go minimize these things and go back to my workspace here. I'm going to refresh my Matlab drive here, and that should show up here if we go back to our Matlab drive. There we go. So here's our logistic PDF. So I'm going to click on that and then go back to Home and click Download, and it downloads my PDF here. And now I've got this really nice high quality figure. Notice if I zoom in, this is all really nice vector graphics. So I get a really nice looking figure here. So I could export that in multiple different formats, not just in PDF. So I could go then incorporate this into my report or publication. To make sure we understand how we can actually use this thing, let's go back into my curve fitting tool here, and let's look at the values that we got here. So I've got my value for L, K, and X sub naught. So I'm going to manually write this equation for just a moment. So I'm going to just type in my fit here, my logistic fit, and I'm going to now type in my equation. So it's going to be is equal to, and then I'm going to just type my equation, except I'm going to substitute in the values. So instead of L, I'm going to put in 0.9945 divided by 1 plus the exponential of minus 1 times, and now that's my K value, or just so I can do minus 3.021, and then I'm going to do times. And then for my X value, I'm going to choose my X value over here, and then I'm going to subtract off X0 1.484, and so I'm just going to close all my parentheses out, click on that value, double click on the corner to expand down. And so now I have evaluated that function at each of my x values here. So I could now add this into my plot here. So I'm going to, first of all, I'm going to get rid of that trend line we made a moment ago because that was not a good fit. And now I'm going to go add that in. So I'm going to select it and I'm going to add a new series. And I'm going to choose, so we'll just call this fit. And then I'm going to do my x values here. So I'm going to choose my x values. And then again, I'm going to choose my y values here. So I'm going to choose my fit values there as that. And so it's going to then add those onto my plot. Right? So now I have my original data, that noisy data, and then I have the stuff that fits my function exactly. So I'm going to edit this for a moment. So just double click there. And I'm going to go look at this. I'm going to tell the marker that, let's see, so I'm going to go to marker options here. And I'm going to tell it I don't want a marker. Oh, I did the wrong thing there. I'm going to choose just my entire data series here. Now I'm going to look at the marker. I want no marker, and instead I want a nice solid line for that. Oh, we didn't get our line there. Let's go back a moment. And we're going to go to line. There we go. We want a solid line. I'm going to turn the marker off again. So no marker. And now I get this nice solid line. I might want to change the color of it so I'll go back to my line here. Something like this. So now you can see there's my original blue data, and then I have my fit that goes right through there. So if I wanted to put it into Excel and then clean up my Excel thing and add on my axis labels, I could do that in Excel and get that custom fit into Excel, even though Excel couldn't do that on its own in the first place. So a couple of nice ways to fit a nonlinear custom function and make some nice figures out of that.